Long before the dinosaurs rose to dominate the Earth, a diverse and astonishing array of creatures ruled the planet, shaping ecosystems in ways that would echo through millions of years of evolution. From sprawling floodplains to shallow lagoons, the Permian and late Carboniferous landscapes teemed with strange and extraordinary life forms. Herbivores with saber teeth, amphibians with spiny sails, and predators that perfected the art of stealth and ambush. These early animals experimented with size, anatomy, and behavior, testing evolutionary strategies that were both innovative and bizarre, far beyond what we see in the world today. In this journey, we will explore the creatures that paved the way for life on Earth, revealing a time when evolution was a relentless force of experimentation, creating astonishing forms that thrived long before the age of dinosaurs. Estemmenosuchus, the horned giant. Long before dinosaurs roamed the Earth, the Permian period was ruled by a menagerie of strange and formidable creatures, each uniquely adapted to a world in flux. Among these early giants stood Estemmenosuchus, a massive herbivorous therapsid that combined an imposing size with a bizarre, horned appearance. Living roughly 265 million years ago, Estemmenosuchus measured up to 3 meters in length, with a wide, barrel-shaped body, sturdy limbs, and a skull adorned with horn-like projections that gave it a fearsome silhouette. These horns were not weapons, but likely used for display and species recognition, providing insight into the complex social behaviors developing in pre-dinosaur ecosystems. Estemmenosuchus's skull was a marvel of early evolutionary experimentation. Thick, bony protuberances rose above the eyes and snout, curving in various directions, creating an intimidating profile to deter predators or rivals. Its jaws were equipped with large, serrated teeth, adapted for cutting tough Permian vegetation, including cycads, seed ferns, and conifers. The musculature of the jaw suggests a powerful bite, capable of processing significant quantities of fibrous plant matter efficiently. Fossil evidence also indicates that the throat and neck were strong, allowing Estemmenosuchus to reach higher vegetation or manipulate food with precision, a vital trait in landscapes where food competition was high. The habitat of Estemmenosuchus was a sprawling, dynamic floodplain punctuated by rivers, lakes, and marshes. Seasonal flooding brought periods of abundance and scarcity, shaping the behaviors of both herbivores and predators. Imagine the Permian morning. Mist rises from muddy banks, ferns drip with dew, and the distant calls of amphibians echo across wetlands. Estemmenosuchus moves deliberately through this landscape, each step heavy but controlled, head slightly lowered, horns catching the soft sunlight. Despite its size, the animal remains alert, aware of lurking predators such as Dimetrodon or Gorgonopsids that may threaten juveniles or stragglers. The floodplain is alive with activity, and every action of Estemmenosuchus influences the ecosystem around it. Social behavior likely played a critical role in the life of Estemmenosuchus. Although direct evidence is scarce, horn patterns and wear suggest ritualized displays, possibly for establishing dominance, attracting mates, or signaling health to others of the species. Herds may have formed for protection and coordinated foraging, allowing individuals to watch for predators while consuming vast amounts of vegetation. Within such a herd, larger individuals likely dominated feeding grounds and territories, while younger or weaker members stayed near the center for protection. These dynamics illustrate that even in the Permian, complex social interactions were shaping the survival and evolution of herbivorous species. Despite its herbivorous diet, Estemmenosuchus was far from defenseless. Its size alone deterred many predators, while its horns and thick skull provided additional protection. In confrontations with rivals, head-butting contests may have allowed males to establish hierarchy without severe injury. The horn's intricate design, combining strength with visual intimidation, demonstrates how evolutionary pressures sculpted both function and display in early synapsids. Juveniles, however, were more vulnerable, relying on cover, herd protection, and agility to survive their formative years. The ecological role of Estemmenosuchus extended beyond feeding. By consuming vast amounts of vegetation, it influenced plant distribution, trampling undergrowth, and creating pathways that smaller animals could follow. Its waste contributed nutrients to soils, promoting plant growth and sustaining other species. The movement patterns of Estemmenosuchus likely shaped the landscape over generations, demonstrating that even a single species can have outsized impacts on its ecosystem. Visualize a day in the life of Estemmenosuchus. The sun rises over the floodplain, warming the humid air. The herd begins its daily migration toward richer feeding grounds, moving deliberately through ferns and low conifers. Juveniles weave among the adults, horns gleaming in the light, while older males assert dominance through subtle displays of posture and horn orientation. Predators may watch from a distance, but the herd's coordinated movements and sheer size serve as a deterrent. Feeding, walking, resting, and observing the daily rhythm is an intricate balance of survival, social interaction, and environmental adaptation. From an evolutionary perspective, Estemmenosuchus exemplifies the experimentation occurring long before the dinosaurs. Its horned skull, massive body, and social behavior represent solutions to multiple challenges: feeding efficiently, avoiding predation, and interacting with conspecifics. Each trait reflects the pressures of a dynamic world, where environmental fluctuations and predator-prey relationships drove innovation. Estemmenosuchus reminds us that the Permian was not a primitive world, but one of complexity, adaptation, and astonishing diversity. As the Permian sun sets, the herd of Estemmenosuchus settles near a river, horns silhouetted against the fading light. Shadows lengthen across the floodplain, predators stir in the distance, and the humid air carries the calls of amphibians and insects. Yet these horned giants remain vigilant and resilient, a testament to the ingenuity of evolution and the richness of life long before the age of dinosaurs. In Estemmenosuchus, we glimpse a world where size, adaptation, and social complexity combine to create a dominant species, shaping the environment and leaving a legacy in the fossil record that continues to fascinate scientists today. Edaphosaurus, the sail-backed herbivore. In the late Carboniferous and early Permian, the Earth was a world of towering forests, vast swamps, and sprawling floodplains, teeming with life that would eventually give rise to the age of reptiles. Among the most remarkable of these early herbivores was Edaphosaurus, a sail-backed synapsid whose strange silhouette dominates the imagination of paleontologists. Measuring up to 3 meters in length, Edaphosaurus was built for a life of browsing dense vegetation, with a massive barrel-shaped body, sturdy limbs, and a distinctive sail rising along its back. This sail, composed of elongated neural spines, was unlike anything seen in modern animals, providing insight into the multiple ways evolution can experiment with form and function. The most striking feature of Edaphosaurus was its sail, which has fascinated scientists for generations. Unlike predators such as Dimetrodon, whose sails may have been used for thermoregulation or intimidation, Edaphosaurus's sail was relatively broad and studded with crossbars along the spines. While its exact function remains debated, evidence suggests it could have served multiple purposes: regulating body temperature by absorbing sunlight, signaling to rivals or mates, or intimidating predators. Imagine a vast Permian swamp at dawn. Mist hovers over the shallow waters, sunlight catches the sail of Edaphosaurus, and the intricate spines reflect a spectrum of colours in the early light, signalling health and strength to others of its species. The skull of Edaphosaurus was small compared to its massive body, but perfectly adapted for a herbivorous lifestyle. Its jaws contained peg-like teeth capable of grinding tough vegetation, including seed ferns, early conifers, and cycads. The musculature of its jaw and neck allowed it to process large quantities of plant material efficiently, supporting its bulk and sustaining energy for foraging and social interactions. Fossil evidence suggests that Edaphosaurus could strip leaves from branches and dig into shallow roots, demonstrating versatility in feeding strategies. These adaptations were crucial for survival in ecosystems where seasonal fluctuations could limit food availability. Edaphosaurus inhabited a complex ecosystem characterized by rivers, floodplains, and dense forests. The landscape teemed with insects, amphibians, and other synapsids, all competing for resources and space. Imagine a morning scene along a riverbank, mist rising from the water, small amphibians calling, insects buzzing overhead, and Edaphosaurus moving deliberately among ferns and low conifers. Its sail casts long shadows across the undergrowth as it feeds, while nearby, smaller herbivores cautiously navigate the same terrain. The presence of Edaphosaurus influenced the behavior of other species, forcing them to adapt, avoid, or coexist in a delicate ecological balance. Social behavior likely played a significant role in Edaphosaurus's life. While evidence for herd behavior is limited, the sail may have served as a visual signal in interactions with others of its species. Males could display their size and fitness through the sail to attract mates or deter rivals, while juveniles may have learned social cues by observing adults. The sail may also have been used to communicate warning signals to conspecifics when predators were nearby. In this way, Edaphosaurus's adaptation was not purely anatomical, but intertwined with its behavior and social strategies, shaping its survival in the complex Permian environment. Despite being a herbivore, Edaphosaurus faced constant threats from predators such as Dimetrodon and larger amphibians. Its sail and considerable size acted as deterrents, while its robust limbs allowed quick retreats into denser vegetation or swampy terrain. Juveniles were particularly vulnerable and likely relied on cover, stealth, and the protection of nearby adults. Fossil evidence of injuries suggests that Edaphosaurus may have survived encounters with predators, indicating resilience and adaptability in its physical design. Every aspect of its anatomy, from sail to jaw to limbs, reflects a balance between feeding, defense, and environmental navigation. The ecological impact of Edaphosaurus extended beyond feeding and predator-prey interactions. By consuming large amounts of vegetation, it shaped the structure of forests and floodplains, creating open spaces and pathways used by smaller animals. Its movement through undergrowth and wetlands redistributed nutrients, facilitated plant growth, and contributed to the overall health of its environment. These interactions demonstrate that Edaphosaurus was more than just a passive herbivore. It was an ecosystem engineer, actively influencing the world around it. Picture a day in the life of Edaphosaurus. The sun climbs higher in the sky, illuminating the sail and casting patterns across the ferns. Individuals move deliberately in search of the best foliage, occasionally pausing to raise their sails in displays of dominance or social communication. Juveniles weave between adults, learning safe pathways and observing predator threats. Predators may lurk in the shadows, but the sail, size, and vigilance of Edaphosaurus provide a constant line of defense. Every movement is calculated, every behavior shaped by survival, reproduction, and the pressures of an ever-changing environment. From an evolutionary perspective, Edaphosaurus illustrates the power of adaptation and experimentation. Its sail demonstrates that even seemingly extravagant structures can serve multiple purposes: thermoregulation, communication, and predator deterrence. Its body shape, feeding adaptations, and potential social behavior highlight the complexity of pre-dinosaur ecosystems, where animals were experimenting with novel forms and strategies to thrive. In Edaphosaurus, we see the ingenuity of life long before the rise of dinosaurs, a creature perfectly adapted to its world and leaving a lasting impression in the fossil record. As twilight descends over the Permian floodplains, Edaphosaurus settles near a river, sail gently swaying in the evening breeze. The calls of amphibians and insects fill the air, shadows stretch across the undergrowth, and predators stir in the distance. Yet these sail-backed giants remain vigilant, resilient, and intricately adapted to their environment. Edaphosaurus reminds us that life before dinosaurs was far from simple. It was a time of complexity, diversity, and astonishing evolutionary creativity, where even herbivores could dominate, shape ecosystems, and captivate the imagination of generations to come. Mesosaurus, early aquatic reptile. While the Permian landscape was dominated by sprawling forests, floodplains, and strange herbivorous giants, another world existed beneath the water's surface, a world of rivers, lagoons, and coastal wetlands teeming with life. Among the earliest vertebrates to explore these watery realms was Mesosaurus, a small but remarkable aquatic reptile that patrolled shallow waters with agility and precision. Living approximately 280 million years ago in regions that are now South America and Africa, Mesosaurus provides a window into early experimentation with aquatic life, demonstrating that evolution was already producing specialists capable of exploiting new and challenging environments long before the rise of dinosaurs. Mesosaurus was a relatively small reptile, measuring about 1 meter in length, yet it was perfectly suited to life in water. Its body was elongated and streamlined, with a long, paddle-like tail that propelled it through shallow rivers and lagoons. Its limbs were adapted for steering rather than walking, resembling modern flippers in function, while its skull was narrow, with elongated jaws filled with sharp, needle-like teeth. These teeth were ideal for grasping slippery prey such as small fish and aquatic invertebrates, indicating that Mesosaurus was an active hunter rather than a scavenger or opportunistic feeder. Its body reflects a delicate balance of speed, flexibility, and maneuverability, allowing it to navigate complex aquatic environments with skill. The habitat of Mesosaurus was a dynamic mosaic of shallow waters, coastal lagoons, and slow-moving rivers. Seasonal fluctuations in water levels created a constantly changing landscape, forcing animals to adapt or perish. Imagine a warm morning in a Permian lagoon. Sunlight pierces through murky water, illuminating floating algae and swaying aquatic plants. Small fish dart through shadows, crustaceans scuttle along the muddy bottom, and Mesosaurus glides silently, eyes focused, tail flicking to adjust position. Its movements are fluid, controlled, and purposeful, demonstrating a mastery of the aquatic environment that few other vertebrates of its time could claim. Mesosaurus's hunting strategy was shaped by both opportunity and caution. Its long, needle-like teeth were designed for gripping small prey rather than crushing, so precision and timing were crucial. Fossil evidence suggests it may have hunted in small groups or schools, increasing efficiency and providing protection against larger predators. The semi-transparent waters of its habitat demanded acute visual acuity and sensitivity to subtle movements, allowing Mesosaurus to detect prey while avoiding threats. Even minor errors could result in missed meals or exposure to predators, highlighting the high-stakes environment of early aquatic ecosystems. Reproduction and social behavior of Mesosaurus remain partially speculative, but studies indicate that they may have laid eggs in sandy banks or shallow waters. This would have required careful timing with seasonal water levels, ensuring that eggs were not washed away or left vulnerable to predators. Juveniles, likely smaller and more vulnerable, may have relied on vegetation for cover or the protection of adults, highlighting the importance of social structures even in early reptiles. These adaptations reflect a delicate balance between life in water and the reproductive strategies needed to ensure species survival. Predation was an ever-present threat. Larger amphibians, aggressive synapsids venturing into shallow waters, and early fish capable of inflicting serious injury all posed dangers. Mesosaurus relied on vigilance, camouflage, and rapid bursts of speed to avoid becoming prey. Dense aquatic vegetation and murky waters provided cover, while schooling behavior may have offered an additional line of defense. The pressures of predation shaped both behavior and anatomy, driving evolutionary refinement in locomotion, sensory perception, and social strategies. The ecological role of Mesosaurus extended beyond its own survival. As a predator of small fish and invertebrates, it influenced the distribution and behavior of prey populations, maintaining balance in its aquatic ecosystem. Its movements through water stirred sediment, redistributed nutrients, and may have affected the growth of aquatic plants. Even a relatively small species like Mesosaurus could have a profound impact on its environment, illustrating the intricate interplay between species that characterizes all ecosystems. Visualize the daily life of Mesosaurus. At dawn, the lagoon is calm, the water reflecting the amber glow of the rising sun. Mesosaurus glides through reeds and submerged plants, mussels rippling beneath smooth scales. Small fish scatter at its approach, while tiny crustaceans scuttle along the muddy bottom. A sudden shadow indicates a predator nearby, and the reptile pauses, tail flicking gently to maintain balance. It waits, calculates, and then continues its hunting, every movement a product of millions of years of evolutionary refinement. From an evolutionary perspective, Mesosaurus represents a crucial step in vertebrate adaptation to aquatic life. Its body plan, elongated, streamlined, and specialized for swimming, prefigures the strategies used by later marine reptiles, such as ichthyosaurs and plesiosaurs, hundreds of millions of years later. Its teeth, limbs, and sensory adaptations reflect a species finely tuned to its niche, demonstrating that life before dinosaurs was not only diverse, but also highly specialized. Mesosaurus reminds us that ecosystems of the Permian were interconnected, dynamic, and full of evolutionary experimentation, with aquatic environments playing as central a role as terrestrial ones. As twilight falls over the Permian lagoon, Mesosaurus rests near the shallows, partially submerged, tail coiled beneath its body. Small fish move cautiously, insects skim the water's surface, and the distant silhouettes of larger predators glide silently through the reeds. In this ancient world, survival depended on vigilance, adaptability, and skillful use of the environment. Mesosaurus, in its unassuming yet extraordinary way, exemplifies the ingenuity of early vertebrate life, a creature perfectly adapted to the challenges of aquatic existence long before the first dinosaurs would roam the land. Tiarajudens, the saber-toothed herbivore. The Permian period was a time of evolutionary experimentation where nature produced forms both bizarre and ingenious. Among the most surprising of these early herbivores was Tiarajudens, a creature that defied expectations with its saber-like teeth. Living approximately 260 million years ago in what is now southern Brazil, Tiarajudens was a medium-sized synapsid, measuring around 1.5 meters in length. Unlike its carnivorous contemporaries, this herbivore bore long, curved canines that seemed designed for attack but served an entirely different purpose. These formidable teeth reveal that evolution often surprises us, producing adaptations that balance feeding, defense, and social interaction in ways that challenge our assumptions. Tiarajudens' most striking feature was undoubtedly its saber-like upper canines. Extending several centimeters beyond the jawline, these teeth were far too fragile for sustained combat with predators, suggesting they evolved for display, defense, or intraspecific competition. Imagine a sunlit Permian plain. A herd of Tiarajudens moves through cycads and ferns, the long canines of adults glinting in the morning light. These teeth may have served as visual signals to rivals, communicating strength, maturity, or social status without the need for lethal combat. In this way, the canines were an elegant solution to the challenges of living in a world populated by both predators and competing herbivores. Despite their fearsome appearance, Tiarajudens was a specialized herbivore. Its jaws contained a series of robust teeth suited for grinding tough plant material, including ferns, seed ferns, and early conifers. This dental arrangement allowed Tiarajudens to extract nutrients efficiently from fibrous vegetation, supporting a high-energy lifestyle necessary for movement, vigilance, and social interactions. Its skull was compact but strong, and the musculature of the jaw allowed repeated chewing motions, enabling it to process large amounts of plant matter with each bite. These adaptations underscore the combination of feeding efficiency and visual signaling that made Tiarajudens so successful. The environment of Tiarajudens was both lush and challenging. Seasonal floods transformed the landscape, creating areas rich in vegetation but also exposing animals to predation. Large predators such as Gorgonopsids and other carnivorous synapsids roamed the same floodplains, while competition for food required herbivores to exploit available niches effectively. Picture a dense Permian floodplain, mist rising from shallow pools, insects humming through the humid air, and a group of Tiarajudens cautiously moving through ferns, heads low, canines raised in warning. Every movement is calculated, every decision influenced by both predation risk and foraging efficiency. Social behavior was likely an important aspect of Tiarajudens' life. The saber-like canines may have been used in ritualized displays or sparring contests among males, establishing dominance without causing severe injury. Herding behavior may have offered additional protection, as individuals could watch for predators while others fed, creating a cooperative network of vigilance. Juveniles likely remained near the herd's center, shielded from both predators and aggressive adults, learning vital survival skills through observation. The interplay of anatomy, behavior, and environment highlights the sophistication of Tiarajudens' adaptation. Predation pressure shaped many aspects of Tiarajudens' behavior and morphology. While the canines were not effective weapons against larger carnivores, the species relied on size, agility, and vigilance for survival. Dense vegetation, burrows, and natural obstacles offered refuge, while alert behavior allowed early detection of threats. Juveniles were especially vulnerable, requiring close proximity to adults and shelter to survive the predation pressures of the Permian floodplains. Each trait, from the positioning of the canines to the robustness of the limbs, reflects an evolutionary response to environmental challenges and predatory threats. Ecologically, Tiarajudens played a significant role in shaping its habitat. By consuming large quantities of plants, it influenced the distribution and growth of vegetation, creating pathways and clearing space for other species. Its waste contributed nutrients to the soil, supporting plant regeneration and sustaining insects and smaller animals. Through these interactions, Tiarajudens acted as a keystone species, indirectly shaping the survival and behaviors of numerous organisms in its ecosystem. Even a medium-sized herbivore could leave a lasting imprint on its environment, demonstrating the interconnectedness of Permian life. Picture a day in the life of Tiarajudens. The sun rises over the floodplain, casting long shadows from ferns and low conifers. The herd moves cautiously, heads lowered, but canines raised in subtle displays of dominance. Juveniles weave among adults, learning safe routes and observing the signs of predators in the distance. A sudden movement in the reeds signals a lurking Gorgonopsid, and the herd freezes, canines glinting as a warning display. Minutes pass before the threat passes, and the herbivores resume feeding and foraging. Every motion, every interaction is a delicate balance between survival, social behavior, and environmental adaptation. From an evolutionary standpoint, Tiarajudens illustrates that adaptation is not always straightforward. Its saber-like teeth, while appearing threatening, were a multifunctional tool for social interaction, defense, and visual communication. Its feeding adaptations ensured survival in a competitive environment, while behavior and vigilance mitigated predation risks. Tiarajudens reminds us that pre-dinosaur ecosystems were dynamic and complex, with species experimenting with novel strategies to navigate the pressures of life long before the first dinosaurs appeared. As twilight settles over the Permian floodplains, Tiarajudens rests near a cluster of cycads, the long canines of adults casting shadows across the undergrowth. Juveniles huddle closer to adults, while predators stir in the distance, their presence felt but not fully threatening. The herd remains vigilant, a testament to the effectiveness of evolutionary design, social cooperation, and environmental awareness. Tiarajudens, in its unusual combination of fearsome appearance and peaceful herbivory, exemplifies the ingenuity of life long before dinosaurs dominated the planet. Platyhystrix, the spiky amphibian. In the lush wetlands and swampy rivers of the late Permian, life was experimenting with form in ways both strange and fascinating. Among the amphibians that thrived in this watery world was Platyhystrix, a medium-sized, semi-aquatic predator distinguished by its unusual sail, a series of flattened spiny projections along its back. Measuring roughly 1 meter in length, Platyhystrix was part of the Temnospondyl lineage, a diverse group of amphibians that dominated freshwater ecosystems long before the arrival of dinosaurs. Its bizarre silhouette, combining a flat body, sprawling limbs, and a spiny sail, reflects the ingenuity of evolution and the diversity of life in the pre-dinosaur world. The sail of Platyhystrix is its most striking feature, rising from elongated vertebrae to create a flattened ridge along its back. This structure may have served multiple purposes, from thermoregulation to display and species recognition. By absorbing sunlight, Platyhystrix could raise its body temperature after long hours in cool water, enhancing mobility and digestion. Alternatively, the sail may have been used in social or sexual signaling, conveying size, health, or maturity to rivals and potential mates. Imagine a foggy Permian morning, the sail catching soft sunlight as Platyhystrix emerges from the water, eyes scanning for prey or predators, its unusual silhouette, both a tool and a warning to others in its environment. The head of Platyhystrix was broad and flattened, filled with small, sharp teeth designed for capturing fish, invertebrates, and smaller amphibians. Its wide mouth allowed it to seize prey with speed, while the muscular jaws ensured a firm grip. Unlike modern frogs or salamanders, Platyhystrix relied on both swimming and walking, moving with agility through shallow waters, muddy banks, and dense vegetation. Its tail, relatively short but powerful, aided in propulsion through water, while its sprawling limbs provided stability on land. This combination of anatomical traits made Platyhystrix a versatile predator in an ecosystem where adaptability was crucial for survival. The environment of Platyhystrix was a complex network of wetlands, rivers, and ponds, dotted with ferns, horsetails, and primitive conifers. Water levels fluctuated seasonally, creating opportunities for feeding, breeding, and refuge from predators. Imagine a warm morning along a Permian swamp. Mist rises from shallow pools, insects hum above the water, and small fish dart through submerged plants. Platyhystrix moves cautiously through the reeds, sail partially exposed, eyes alert. Every movement is a careful calculation, balancing the need to hunt with the ever-present threat of predators lurking nearby. Behavioral strategies of Platyhystrix were likely multifaceted. Its sail may have functioned in ritualized displays, both to intimidate rivals and to attract mates. Males could raise their spines, making their bodies appear larger and more imposing, while juveniles learned these social cues through observation. Such behavior suggests that even early amphibians were experimenting with complex social interactions, using anatomical adaptations to communicate status and fitness without resorting to violence. The combination of anatomy and behavior highlights the evolutionary sophistication present long before the rise of dinosaurs. Predation was a constant concern. Larger amphibians, early synapsids like Gorgonopsids, and other semi-aquatic predators posed threats to Platyhystrix, particularly to juveniles or weakened individuals. To survive, it relied on camouflage, dense vegetation, and quick bursts of speed in water. Its flattened body allowed it to remain partially submerged and hidden, while the sail may have served as a visual deterrent, making it appear larger than it truly was. Fossil evidence suggests that Platyhystrix experienced injuries and regrowth, indicating that encounters with predators were frequent but survivable, shaping both behavior and anatomy over generations. Ecologically, Platyhystrix played a crucial role in its habitat. By preying on small fish and invertebrates, it regulated populations and maintained balance within freshwater ecosystems. Its movements stirred sediment, redistributed nutrients, and influenced plant growth along riverbanks. The presence of Platyhystrix shaped the behavior of prey species and provided a selective pressure that contributed to evolutionary innovation in aquatic and semi-aquatic life. Even a single medium-sized amphibian could have far-reaching impacts, demonstrating the interconnectedness of Permian wetlands. Picture a day in the life of Platyhystrix. Dawn breaks over the swamp, sunlight filtering through ferns and conifers. Platyhystrix glides silently through shallow water, muscles tensed, tail flicking to navigate reeds. A small fish ventures too close to the bank, and with a sudden lunge, the amphibian captures it. Later, it retreats to the muddy shore, partially hidden among vegetation, sail exposed in a subtle display of size to warn others or assert dominance. Each action is a delicate balance of hunting, social interaction, and environmental awareness, reflecting the pressures and challenges of life in Permian wetlands. From an evolutionary perspective, Platyhystrix demonstrates the diversity of life before dinosaurs. Its sail, semi-aquatic adaptations, and complex behaviors show how even amphibians were experimenting with novel strategies for survival. Its presence influenced prey populations, predator behavior, and habitat dynamics, highlighting the sophisticated ecological webs that existed long before the age of dinosaurs. Platyhystrix reminds us that prehistoric life was full of creativity, innovation, and adaptation, with species exploiting every niche available to survive and thrive. As the Permian sun sets, Platyhystrix settles in shallow water, partially submerged, eyes scanning for movement. Insects and amphibians grow quiet, predators lurk in distant shadows, and the wetland takes on a calm, reflective stillness. Yet Platyhystrix remains vigilant, a survivor finely tuned to its environment, a creature that embodies the ingenuity and adaptability of life long before the first dinosaurs walked the earth. Its story offers a glimpse into a world of ecological complexity and evolutionary experimentation, where even the most unusual adaptations could ensure survival in a challenging and ever-changing environment. Ophiacodon, the early predator. While many Permian creatures were experimenting with herbivory or social displays, some species perfected the art of predation. Among these hunters was Ophiacodon, a formidable synapsid that prowled rivers, swamps, and floodplains roughly 300 million years ago. Measuring up to 3.5 meters in length, Ophiacodon combined a slender, elongated body with a powerful bite, making it one of the most effective predators of its ecosystem. Its anatomy, behavior, and habitat reveal the sophistication of early predatory strategies long before the rise of dinosaurs, demonstrating that even mid-level predators played a crucial role in shaping ecosystems. The skull of Ophiacodon was long and narrow, filled with sharp, conical teeth optimized for gripping and tearing soft flesh. Unlike the crushing jaws of later apex predators, these teeth allowed precise capture of prey, such as fish, amphibians, and smaller synapsids. The jaws could snap shut quickly, while powerful neck muscles ensured strength and speed in the capture. Its eyes were positioned to provide a wide field of vision, essential for detecting prey from a distance or tracking movement in murky waters. Nostrils near the top of its elongated snout allowed Ophiacodon to breathe while partially submerged, giving it a stealthy advantage when approaching unsuspecting prey along riverbanks. Ophiacodon's body was slender and elongated, with relatively short but muscular limbs. This build allowed it to move efficiently both in water and on land, favouring ambush over prolonged chases. Its long, flexible tail provided balance and propulsion in aquatic environments, while its compact limbs enabled sudden bursts of speed to capture prey. Imagine a Permian floodplain at dawn. Mist rises over slow-moving water, fish break the surface, and Ophiacodon glides silently through reeds. Its body tenses, jaws ready, as it prepares to strike with precision, a testament to millions of years of evolutionary refinement. The habitat of Ophiacodon was dynamic, consisting of rivers, marshes, and floodplains, with vegetation ranging from low ferns to cycads and horsetails. Seasonal flooding created both opportunity and risk, shaping the predator's movements and hunting strategies. Small amphibians and fish abounded in these waterways, offering abundant prey, while larger predators, such as Dimetrodon, loomed nearby, posing constant threats. Survival required vigilance, adaptability, and acute sensory perception, traits that Ophiacodon had honed to perfection. Hunting strategies were diverse and sophisticated. Ophiacodon relied on stealth and ambush, using vegetation or shallow water as cover while waiting for prey. Its conical teeth were ideal for seizing slippery animals, while the long tail and flexible body allowed rapid directional changes during pursuit. Fossil evidence suggests that Ophiacodon could exploit both terrestrial and semi-aquatic niches, hunting along riverbanks as well as within water. This versatility gave it a predatory advantage in ecosystems that included both aquatic and terrestrial prey, illustrating the dynamic pressures shaping early synapsid evolution. Social behavior in Ophiacodon is less clear, but its interactions with both competitors and prey were critical to survival. Larger predators may have occasionally targeted Ophiacodon, particularly juveniles, forcing it to develop escape strategies such as diving into water or hiding in dense vegetation. Its body design, combining speed, stealth, and agility, reflects these pressures. In turn, its predatory habits influence prey populations, driving the evolution of defensive behaviors such as camouflage, burrowing, and group vigilance among fish and amphibians. Ophiacodon was both a predator and an agent of evolutionary change, shaping the behavior and morphology of the species around it. Ecologically, Ophiacodon was a mid-level predator with a significant role in maintaining balance within its ecosystem. By hunting smaller vertebrates, it regulated population sizes and influenced the behavior of prey species. Its presence may have created selective pressures for speed, alertness, and social cooperation in prey, while also competing with other semi-aquatic predators for food. Fossil evidence shows wear patterns on teeth and bones, suggesting repeated hunting and interactions that further illustrate its role in ecosystem dynamics. Even as a predator, Ophiacodon contributed to the stability and complexity of its environment. Imagine a day in the life of Ophiacodon. The sun rises, casting dappled light across reeds and riverbanks. The predator glides silently through shallow water, tail flicking to maintain position. Fish dart between submerged plants, and small amphibians hop cautiously along the banks. A shadow signals potential danger, a larger predator in the distance. Ophiacodon pauses, senses heightened, waiting for the right moment to strike or retreat. The balance between hunting success and survival is delicate, and every decision shapes the predator's fate in this Permian world. From an evolutionary perspective, Ophiacodon illustrates the experimentation and refinement of predatory strategies long before dinosaurs dominated terrestrial ecosystems. Its body design, teeth, and behavior reflect solutions to multiple challenges: capturing prey efficiently, avoiding larger predators, and navigating both aquatic and terrestrial environments. Ophiacodon reminds us that life before dinosaurs was a time of innovation, with species continually adapting to survive and influence the world around them. It embodies the sophistication, agility, and cunning that allowed early predators to thrive in complex and competitive ecosystems. As twilight settles over a Permian floodplain, Ophiacodon rests partially submerged, eyes above the water, alert for movement. Small fish move cautiously in the fading light. Amphibians pause along the banks, and the distant silhouettes of larger predators shift in shadows. Yet Ophiacodon remains vigilant, a master of stealth and precision, a predator perfectly adapted to its environment. Its story highlights the delicate balance of life long before dinosaurs, demonstrating that even early synapsids could dominate, influence, and thrive in the dynamic, interconnected ecosystems of the Permian. Dimetrodon, apex predator of the Permian. In the ever-changing landscapes of the Permian period, few creatures captured the imagination of paleontologists more than Dimetrodon, a predator whose distinctive sail and formidable build made it one of the dominant synapsids of its time. Living roughly 295 million years ago in what is now North America, Dimetrodon was not a dinosaur, but a mammal-like reptile that perfected the role of apex predator long before the rise of true reptiles. Measuring up to 4 meters in length, its muscular body, sharp teeth, and distinctive dorsal sail reveal a creature finely adapted to hunting, display, and thermoregulation in a dynamic and competitive ecosystem. The most iconic feature of Dimetrodon is its sail, formed from elongated neural spines extending from the vertebrae along its back. This sail was likely multifunctional, serving as a thermoregulatory device, a visual display for social interaction, and a tool for intimidation. By adjusting the angle of its body to the sun, Dimetrodon could warm itself in the morning or release heat during the midday sun, optimizing energy levels for hunting and other activities. Imagine a Permian river valley at sunrise. Dimetrodon rises from the shade of ferns, sail illuminated, casting long shadows across the ground as the predator prepares to patrol its territory. The sail's intricate structure is not just functional, but also a statement of evolutionary ingenuity. Dimetrodon's skull was large and powerful, with jaws capable of delivering devastating bites. Its teeth were differentiated, hence the name Dimetrodon, meaning 2 types of teeth, with sharp incisors for piercing flesh and serrated teeth for tearing prey. This arrangement allowed Dimetrodon to tackle a wide variety of prey, from amphibians and small synapsids to larger herbivores like Edaphosaurus. Strong neck muscles and a robust skeletal structure supported the skull, ensuring that each strike could incapacitate prey efficiently. Fossil evidence suggests that Dimetrodon was an active hunter, capable of stalking, ambushing, and overpowering animals larger than itself, a true apex predator of its era. The habitat of Dimetrodon was varied, ranging from river valleys and floodplains to open woodlands and swampy marshes. Seasonal variations in water availability created both challenges and opportunities for hunting. Predators like Dimetrodon needed to monitor shifting water levels, prey migrations, and the presence of rival carnivores. Picture a humid Permian morning. Insects buzz through ferns, small amphibians leap cautiously, and Dimetrodon moves silently along the riverbank, eyes scanning for movement. Its presence shaped the behavior of prey and competitors alike, establishing a dynamic ecosystem where survival demanded constant awareness and strategic action. Behaviorally, Dimetrodon was likely territorial, using its sail for both intimidation and communication. Males may have engaged in ritualized displays to establish dominance, with larger sails signaling strength and health to rivals and potential mates. These visual displays reduced the need for combat, lowering the risk of injury while maintaining social hierarchy. Juveniles observed and learned these behaviors, gradually understanding the complex social cues that governed interactions within the species. Such displays highlight the sophistication of social dynamics among early synapsids, long before mammals or dinosaurs would evolve similar behaviors. Predation by Dimetrodon was both precise and opportunistic. Using stealth, patience, and bursts of speed, it could ambush prey along riverbanks or in open areas. Its limbs allowed both crawling and short bursts of sprinting, while its tail provided balance during sudden lunges. Fossil evidence, including bite marks and healed injuries on prey, indicates that Dimetrodon engaged in repeated hunting interactions, honing its skills over a lifetime. The combination of anatomy, intelligence, and strategy made Dimetrodon a dominant force, influencing the distribution, behavior, and evolution of numerous species in its ecosystem. The ecological impact of Dimetrodon extended beyond its direct predatory actions. By regulating populations of herbivores and smaller predators, it maintained balance within its ecosystem. Prey species adapted to avoid detection, developing camouflage, burrowing behavior, or coordinated vigilance. Even minor shifts in Dimetrodon behavior could ripple through the food web, affecting plant growth, predator-prey dynamics, and overall ecological stability. This apex predator was both a regulator and a catalyst, driving evolutionary pressures across multiple trophic levels in the Permian landscape. Imagine a day in the life of Dimetrodon. The sun rises over a broad floodplain, casting golden light across ferns and horsetails. Dimetrodon glides silently through shadows, sail partially illuminated, eyes scanning for movement. A juvenile Edaphosaurus wanders too close to a water source, unaware of the predator's presence. Dimetrodon tenses, tail flicking, before lunging with remarkable speed. The hunt is brief, precise, and effective. Later, it retreats to the shade, sail adjusted to absorb warmth, conserving energy while remaining alert to competitors and threats. Each action is a blend of instinct, learned behavior, and anatomical specialization, reflecting millions of years of evolutionary refinement. From an evolutionary perspective, Dimetrodon represents a pinnacle of predatory adaptation in the Permian. Its differentiated teeth, powerful jaws, agile body, and multifunctional sail reflect a creature perfectly suited to its niche. As an apex predator, it shaped the behavior, morphology, and survival of numerous species, influencing ecosystems in ways that would echo through deep time. Dimetrodon reminds us that life before dinosaurs was dynamic, complex, and full of evolutionary creativity, with species exploring diverse strategies to dominate, survive, and thrive in challenging environments. As dusk settles over the Permian floodplain, Dimetrodon rests near a river, partially concealed by ferns, sails silhouetted against the fading light. Insects quiet, amphibians retreat, and the distant shapes of other synapsids pass silently through the shadows. Yet Dimetrodon remains vigilant, a master of predation, a force shaping life around it, and a symbol of the ingenuity and power of pre-dinosaur evolution. Its story highlights the delicate balance of life, demonstrating how apex predators influence, dominate, and thrive in dynamic ecosystems, long before the age of dinosaurs began. Gorgonopsid, saber-toothed predator. In the late Permian, the Earth was a realm of evolutionary experimentation, where predators and prey were locked in a delicate balance of survival and adaptation. Among the most formidable hunters of this era were the Gorgonopsids, a group of saber-toothed synapsids that reigned over terrestrial ecosystems long before the first dinosaurs appeared. Measuring up to 3 meters in length, these predators combined a powerful, elongated skull, specialized canines, and a muscular, agile body, creating a predator capable of dominating floodplains, woodlands, and open landscapes alike. Gorgonopsids offer a glimpse into the sophisticated predatory strategies that evolved during the Permian, revealing a world of danger, competition, and ecological complexity. The most striking feature of Gorgonopsids was their elongated, saber-like canines protruding from an otherwise narrow and powerful skull. Unlike herbivorous saber-toothed synapsids, these teeth were designed explicitly for hunting, capable of slicing through flesh and delivering lethal bites to large prey. The jaws of Gorgonopsids were reinforced with strong muscles, allowing them to clamp down with precision and force. Fossil evidence suggests that they could hunt both small, agile prey and larger herbivores, such as Edaphosaurus or Tiarajudens, demonstrating versatility in feeding strategies. Imagine a Permian evening. The sun dips behind distant hills, and a Gorgonopsid crouches in the undergrowth, canines gleaming in the fading light, ready to strike with speed and efficiency. The body of the Gorgonopsid was slender yet muscular, built for ambush hunting rather than long pursuits. Its limbs were positioned beneath the body more than in earlier synapsids, allowing greater mobility, balance, and bursts of speed. The tail provided stability during rapid lunges, while the strong neck and shoulder muscles ensured that the powerful skull could be wielded with precision. These adaptations made Gorgonopsids exceptional predators, able to stalk, ambush, and overpower prey in complex terrains of ferns, horsetails, and primitive conifers. Even their posture reveals an evolutionary refinement, bridging the gap between sprawling reptiles and more upright, mammal-like movement. The habitat of Gorgonopsids was diverse, including river valleys, floodplains, and forested landscapes, where prey was abundant but competition was fierce. Seasonal changes brought periods of abundance, when herbivores roamed open areas, and scarcity, when hunting required patience, cunning, and strategic movement. Imagine the Permian dawn. Mist drifts across the floodplain, amphibians croak from shallow pools, and herbivores begin to forage for morning food. A Gorgonopsid lurks in the shadows, scanning for opportunity, muscles tensed, ready to exploit even the slightest lapse in vigilance by its prey. Every step, pause, and motion reflects evolutionary pressure, honed over millions of years. Behaviorally, Gorgonopsids were likely solitary or hunted in small, loosely coordinated groups. The canines played roles beyond hunting, possibly signaling dominance, health, or maturity to rivals. Ritualized displays may have reduced the need for dangerous combat while reinforcing social hierarchies among males. Juveniles, vulnerable to both predators and competition, likely relied on stealth, cover, and learning from adults to survive. The combination of anatomical specialization and behavioral sophistication shows that Permian predators were not simple creatures. They were strategic, adaptable, and remarkably efficient hunters. Predation by Gorgonopsids was precise and deadly. Using stealth, camouflage, and rapid bursts of speed, they could ambush prey in a variety of environments. Fossil evidence shows healed bite marks on prey species, indicating repeated hunting interactions and selective targeting. Larger herbivores were not exempt, and Gorgonopsids may have focused on weaker, injured, or juvenile individuals. Their hunting methods shaped the evolution of prey behavior, driving vigilance, defensive postures, and escape strategies across multiple species. Every successful hunt reinforced the predator's role in the ecosystem while influencing the evolutionary trajectory of its prey. Ecologically, Gorgonopsids were keystone predators, exerting control over prey populations and influencing the structure of their environment. By targeting specific species and sizes of prey, they created selective pressure that promoted diversity and adaptation among herbivores. Their presence affected movement patterns, feeding behavior, and social structures of prey species, demonstrating how a single predator could ripple through an ecosystem. Gorgonopsids were not just hunters, they were ecosystem engineers, shaping the dynamic balance of life long before the age of dinosaurs. Picture a day in the life of a Gorgonopsid. The sun rises over the Permian floodplain, casting warm light on ferns and low conifers. Juvenile herbivores move cautiously through open areas, alert to potential predators. A Gorgonopsid lies in ambush, muscles coiled, eyes tracking movement, canines gleaming. A smaller synapsid wanders too close, and in an instant, the predator lunges, jaws closing with lethal precision. The hunt is brief, successful, and essential for survival. Later, the predator rests in shaded vegetation, tail flicking, head raised to monitor competitors, illustrating the delicate balance between hunting, energy conservation, and vigilance in the Permian world. From an evolutionary standpoint, Gorgonopsids represent a pinnacle of predatory adaptation before dinosaurs emerged. Their saber-like canines, powerful jaws, and agile bodies allowed them to exploit prey niches with efficiency unmatched by contemporaries. By shaping prey populations and influencing ecosystem dynamics, Gorgonopsids played a central role in the evolutionary drama of the Permian. They remind us that life before dinosaurs was not primitive, it was complex, strategic, and full of evolutionary innovation, with predators experimenting with every possible advantage to dominate their environment. As twilight descends over the Permian floodplain, the Gorgonopsid rests, partially hidden among ferns and low vegetation. Shadows lengthen, small prey species retreat, and distant predators stir in the dimming light. Yet the Gorgonopsid remains vigilant, a master of stealth, precision, and adaptation. Its story illustrates the ingenuity and effectiveness of pre-dinosaur predators, showing how life evolved specialized forms to dominate, survive, and thrive in complex ecosystems long before the dinosaurs would rise to power. Lystrosaurus, survivor of catastrophe. Among the myriad creatures that roamed the Permian and Triassic landscapes, Lystrosaurus stands out as one of the most remarkable examples of resilience and survival. Living approximately 250 million years ago, this herbivorous synapsid endured one of the most devastating events in Earth's history, the Permian Triassic mass extinction, which wiped out nearly 90% of species. Lystrosaurus's anatomy, behavior, and adaptability allowed it to not only survive but thrive in post-extinction ecosystems, offering a window into how life persisted, adapted, and reshaped the planet's terrestrial environments long before the age of dinosaurs. Lystrosaurus was a robust, stocky animal, measuring roughly 1 meter in length. With a barrel-shaped body, short, powerful limbs, and a large, forward-facing head. Its tusk-like teeth were uniquely adapted for uprooting plants, stripping roots, and chewing tough vegetation. Unlike its predecessors, which often relied on specialized diets, Lystrosaurus exhibited remarkable dietary flexibility, allowing it to exploit a variety of plant sources in a world struggling to recover from mass extinction. Imagine a barren Triassic plain, scorched soil, sparse vegetation, and clusters of resilient Lystrosaurus foraging, tusks digging into roots, heads lowering and raising in rhythmic precision as they gather the nutrients needed to survive. The skull of Lystrosaurus was heavily built, with a beak-like structure and 2 protruding tusks. These tusks were not weapons for combat, but tools for feeding, capable of pulling apart fibrous plant material and breaking through soil to access roots. Its strong jaw muscles and specialized teeth enabled efficient processing of vegetation, essential in a world where resources were scarce. This adaptation, combined with a compact yet powerful body, allowed Lystrosaurus to thrive when other species struggled, demonstrating that survival often favored flexibility and resilience over sheer size or aggression. Lystrosaurus inhabited a harsh, often unstable landscape. Post-extinction ecosystems were characterized by limited vegetation, fluctuating water sources, and extreme climatic conditions. Survival demanded ingenuity, energy efficiency, and vigilance. Herding behavior likely played a role, providing safety in numbers and allowing individuals to share knowledge of food sources and hazards. Imagine a group of Lystrosaurus moving cautiously across a floodplain, scanning for both food and potential predators. Every action is dictated by the need to conserve energy, avoid danger, and exploit whatever resources remain, highlighting the pressures faced by survivors of planetary catastrophe. Behaviorally, Lystrosaurus may have exhibited both social and defensive strategies. Herding could have protected juveniles from predators, while adult vigilance ensured that threats were detected early. Fossil evidence suggests occasional injuries, implying interactions with predators such as Gorgonopsids or larger Triassic therapsids. Despite these dangers, Lystrosaurus persisted, relying on both physical adaptations and behavioral strategies to navigate a post-extinction world. Its ability to move, feed, and reproduce in challenging conditions exemplifies the ingenuity of life in periods of extreme stress. Predation shaped many aspects of Lystrosaurus's survival. Its stocky body, low center of gravity, and short limbs allowed it to brace against attacks, while tusks may have been used to intimidate or fend off smaller predators. Juveniles were likely more vulnerable, relying on group protection and hidden foraging areas. In this environment, natural selection favored individuals capable of adapting to scarcity, maintaining energy balance, and avoiding predation. Every anatomical and behavioral trait of Lystrosaurus contributed to a remarkable record of survival in a world hostile to life. Ecologically, Lystrosaurus played a crucial role in shaping early Triassic landscapes. By feeding on sparse vegetation, it helped recycle nutrients, promote plant regrowth, and maintain the balance of emerging ecosystems. Its presence influenced predator-prey dynamics, facilitated the survival of other herbivores by creating cleared spaces, and contributed to the gradual stabilization of terrestrial ecosystems. In essence, Lystrosaurus was not merely a survivor, it was a keystone species in the recovery of life after one of Earth's greatest crises. Picture a day in the life of Lystrosaurus. Dawn breaks over a recovering floodplain, the air heavy with mist and the scent of damp soil. Herds move slowly across sparse vegetation, tusks scraping the ground for roots, heads dipping and rising in a rhythm honed by necessity. Juveniles follow adults closely, learning where to find water and shelter. Predators lurk in the distance, but vigilance, herd coordination, and resilience allow survival. The harsh environment demands constant adaptation, shaping behavior, diet, and social interactions in ways that ensured Lystrosaurus could endure when many others perished. From an evolutionary perspective, Lystrosaurus exemplifies the power of resilience, adaptability, and ecological flexibility. Its specialized feeding structures, robust body, and social behavior allowed it to survive mass extinction events, illustrating that survival is often less about dominance and more about innovation, versatility, and endurance. Lystrosaurus reminds us that life before and after the Permian Triassic extinction was complex, dynamic, and full of strategies to cope with extreme environmental pressures. Its legacy is a testament to the evolutionary creativity that shaped the pre-dinosaur world. As the sun sets over the recovering Triassic landscape, herds of Lystrosaurus gather near water sources, tusks scraping roots, heads moving rhythmically as they feed. Shadows lengthen, predators grow cautious, and the survivors persist in a world still fragile and dangerous. Lystrosaurus embodies resilience, adaptability, and the quiet ingenuity of life, demonstrating that even in the aftermath of catastrophe, species can endure, thrive, and lay the foundations for the ecosystems that would eventually support dinosaurs. Its story is a reminder that evolution is not just about grandeur or size, but about persistence, flexibility, and the ability to seize opportunity in even the harshest circumstances. Postosuchus, Triassic apex predator. The Triassic period marked a new era in Earth's history, following the devastating Permian-Triassic extinction. As ecosystems recovered, new predators emerged to dominate the recovering landscapes. Among the most fearsome of these was Postosuchus, a massive archosaur that patrolled river valleys, floodplains, and open woodlands approximately 230 million years ago. Measuring up to 5 meters in length, Postosuchus combined incredible power, speed, and intelligence, becoming one of the apex predators of its time. Its anatomy and hunting strategies reveal a creature finely tuned for predation, capable of influencing entire ecosystems long before the first true dinosaurs ruled the land. Postosuchus was a formidable sight, with a deep, robust skull filled with serrated teeth designed to puncture and tear flesh. Unlike smaller predators, it could tackle large prey with efficiency, from herbivorous Anteosaurs to early Dicynodonts. Its jaws were capable of exerting immense force, while powerful neck and shoulder muscles enabled rapid strikes and precise control during attacks. The teeth were angled for grip and penetration, ensuring that prey could not easily escape once caught. Imagine a Triassic floodplain at dawn. The massive predator prowls silently along riverbanks, nostrils flaring, eyes scanning for movement, ready to strike with lethal precision. The body of Postosuchus was muscular and elongated, built for both endurance and bursts of speed. Long, powerful legs positioned beneath the body allowed agile movement on land, while a robust tail provided balance during rapid turns or lunges. Its stance, more upright than earlier synapsids, enabled efficient locomotion over varied terrain, from muddy riverbanks to open plains. These adaptations allowed Postosuchus to be an opportunistic hunter, capable of stalking, ambushing, and overpowering prey across diverse landscapes. Its combination of size, speed, and power made it a dominant predator in early Triassic ecosystems. Postosuchus inhabited a dynamic and often dangerous environment. Seasonal flooding, shifting vegetation, and competition from other carnivores created a landscape where survival demanded vigilance, adaptability, and cunning. Prey species, such as Lystrosaurus and other herbivorous synapsids, moved cautiously through floodplains, constantly alert to the threat of ambush. Imagine the rising sun over a Triassic woodland. Mist clings to low ferns. Small herbivores graze cautiously, and Postosuchus waits, partially concealed, muscles coiled, eyes scanning for a lapse in vigilance. Every step and motion reflects evolutionary pressures honed over millions of years. Behaviorally, Postosuchus may have been solitary, relying on stealth and strategic positioning rather than coordinated hunting. Its massive size and formidable capabilities allowed it to dominate smaller predators and influence prey distribution. Displays of dominance may have occurred through physical posturing, vocalizations, or visual signals, though direct evidence is limited. Juveniles likely relied on concealment, cover, and learning from adults to survive, highlighting the importance of behavior in complementing physical adaptations for survival in complex Triassic ecosystems. Predation by Postosuchus was precise and devastating. Using stealth and sudden bursts of speed, it could ambush prey in open areas or along riverbanks. Fossil evidence, including puncture marks and healed injuries on prey species, indicates repeated interactions and selective hunting. Even large herbivores could be taken down through calculated attacks, exploiting both anatomy and strategy. Its role as an apex predator influenced prey populations, driving defensive adaptations such as vigilance, burrowing, and group behavior, and shaping the broader ecological landscape. Ecologically, Postosuchus was a keystone species, shaping the structure and dynamics of early Triassic ecosystems. By preying on herbivores and competing carnivores, it regulated populations and maintained balance across multiple trophic levels. Its presence affected feeding behavior, movement patterns, and social structures of prey, illustrating the profound impact a single apex predator could have on its environment. Postosuchus demonstrates that predator-prey dynamics, competition, and ecological influence were already sophisticated during the Triassic, long before dinosaurs would dominate the Mesozoic. Picture a day in the life of Postosuchus. The sun rises over a floodplain dotted with low vegetation and scattered ferns. A herd of Lystrosaurus grazes cautiously, unaware of the predator lurking nearby. Postosuchus moves silently, tail flicking for balance, nostrils twitching as it senses movement. A small herbivore strays too close to the water, and in an instant the predator lunges, jaws closing with lethal force. Later, it rests in the shade of a fallen log, muscles relaxed but senses alert, scanning for threats or opportunity. Every action balances hunting efficiency, energy conservation, and environmental awareness in a challenging and competitive world. From an evolutionary perspective, Postosuchus represents the apex predator archetype of the early Triassic. Its combination of size, strength, speed, and intelligence allowed it to dominate prey and competitors alike. By shaping ecosystems, influencing prey behavior, and competing with other carnivores, Postosuchus exemplifies the sophistication and complexity of pre-dinosaur predation. Its story reminds us that the Triassic world was not a simple transitional phase. It was a dynamic arena of adaptation, strategy, and survival, where apex predators played pivotal roles in shaping life's trajectory. As twilight falls over a Triassic floodplain, Postosuchus rests near a river, partially concealed by ferns, muscles coiled for any sudden movement. Small herbivores retreat, insects quiet, and distant predators stir in the shadows. Yet Postosuchus remains alert, a master of strategy, speed, and power, an apex predator perfectly adapted to its environment. Its story illustrates the ingenuity, adaptability, and dominance of life before true dinosaurs, highlighting the complex ecological interactions and evolutionary experiments that paved the way for Mesozoic life. Thrinaxodon, small but clever predator. While the Permian and early Triassic were dominated by massive predators like Gorgonopsids and Postosuchus, smaller, agile hunters were equally critical in shaping ecosystems. One such predator was Thrinaxodon, a small, mammal-like cynodont that prowled the southern continents approximately 250 million years ago. Measuring roughly 50 centimeters to 1 meter in length, Thrinaxodon combined agility, intelligence, and specialized anatomy to thrive in a world recovering from mass extinction. Though diminutive compared to apex predators, its role as a mid-level predator was vital, influencing both prey populations and ecological dynamics across its environment. Thrinaxodon's skull was compact but highly adapted for predation. Its teeth were differentiated, featuring sharp incisors for grasping and slicing, and molar-like postcanines suitable for processing small vertebrates and insects. Unlike larger predators that relied on brute strength, Thrinaxodon's success depended on speed, precision, and cunning. Fossil evidence suggests a semi-burrowing lifestyle, with adaptations that allowed it to dig or seek shelter underground. Imagine a misty Permian floodplain at dawn, Thrinaxodon emerges cautiously from a burrow, whiskers twitching, eyes scanning for insects, amphibians, or juvenile synapsids, every sense alert to both prey and predators. The body of Thrinaxodon was slender and muscular, with strong forelimbs and claws capable of digging or grasping. Its long tail provided balance while navigating uneven terrain or making rapid turns during a chase. Hind limbs were slightly longer, enabling swift movement across the forest floor or through underbrush. These features made Thrinaxodon an efficient hunter and forager, capable of exploiting resources unavailable to larger, slower predators. Its combination of agility and flexibility reflects evolutionary refinement in small carnivorous synapsids, demonstrating that survival did not always depend on size or brute force. Thrinaxodon inhabited diverse habitats, from floodplains to semi-arid scrublands, often burrowing into soil or under vegetation for shelter. Seasonal variations in rainfall and food availability created a challenging environment, favouring adaptable foragers that could exploit both surface and subterranean niches. Picture a warm afternoon. Small amphibians hop between puddles, insects buzz through low ferns, and Thrinaxodon stalks silently along the edge of a riverbank, muscles coiled, ready to pounce on unsuspecting prey. Its presence shaped prey behaviour, encouraging vigilance, camouflage, and rapid escape strategies, even among the smallest animals. Behaviourally, Thrinaxodon displayed remarkable intelligence for its size. Its burrowing tendencies suggest it sought protection from larger predators, harsh weather, or environmental extremes. Fossil evidence shows juveniles preserved within burrows alongside adults, indicating parental care or social tolerance, a sophisticated behaviour uncommon in many contemporary synapsids. By utilising both intelligence and physical adaptations, Thrinaxodon was able to survive in an ecosystem where larger predators dominated, demonstrating that brainpower and strategy could rival sheer strength in evolutionary success. Predation by Thrinaxodon was precise and opportunistic. It targeted insects, small amphibians, and juvenile herbivores, using stealth, quick reflexes, and rapid bursts of speed. Its sharp claws and teeth enabled it to immobilize prey efficiently, while its flexible body allowed agile maneuvers in dense undergrowth or shallow water. Fossil evidence of bite marks on small vertebrates suggests repeated hunting success, highlighting its adaptability and skill. By controlling populations of smaller animals, Thrinaxodon indirectly influenced vegetation, prey dynamics, and the behavior of other predators in its environment. Ecologically, Thrinaxodon was a keystone mid-level predator. Its ability to exploit both surface and subterranean niches allowed it to fill a unique ecological role, balancing populations of insects, amphibians, and small synapsids. Its burrowing activity aerated soil, modified microhabitats, and provided shelter opportunities for other species, demonstrating that even small predators could have wide-reaching environmental impacts. By occupying a versatile niche, Thrinaxodon contributed to ecosystem stability and resilience during a period of ecological recovery. Picture a day in the life of Thrinaxodon. Morning sunlight filters through sparse ferns, dew clinging to leaves. Small amphibians leap across puddles, insects hum in the air, and Thrinaxodon slips quietly from its burrow. Every muscle is tensed, tail balancing, claws poised to seize prey. A juvenile amphibian wanders into range, and with a rapid pounce, the predator secures its meal. Later, Thrinaxodon retreats to a shaded burrow to rest, eyes alert, listening for the approach of larger predators. Its day is a constant interplay of hunting, survival, and adaptation, a testament to evolutionary ingenuity in a challenging world. From an evolutionary perspective, Thrinaxodon represents a critical stage in the rise of mammal-like synapsids. Its combination of intelligence, agility, burrowing behavior, and precise predation demonstrates that evolutionary success is not solely about size or strength. By shaping prey populations, influencing ecological interactions, and occupying versatile niches, Thrinaxodon exemplifies how small predators thrived in pre-dinosaur ecosystems. It reminds us that life before dinosaurs was complex, dynamic, and full of strategic adaptation, where survival depended as much on cunning and flexibility as on brute force. As twilight falls over the Permian floodplain, Thrinaxodon returns to its burrow, partially concealed by ferns and soil mounds. Small prey retreat, predators roam cautiously, and the world becomes a landscape of shadows and whispers. Yet Thrinaxodon remains alert, a master of strategy, agility, and survival. Its story illustrates the ingenuity of pre-dinosaur predators, showing how even small, overlooked species could dominate ecological niches, influence evolution, and persist in a world still recovering from catastrophe. Dicynodonts, powerful herbivores. While predators like Gorgonopsids and Postosuchus captured attention with their strength and cunning, herbivores played an equally crucial role in shaping pre-dinosaur ecosystems. Among the most successful and widespread of these were Dicynodonts, mammal-like synapsids that flourished from the late Permian into the Triassic. Their name, meaning two dog teeth, refers to their prominent tusks, while their heavily built bodies allowed them to process tough vegetation efficiently. Dicynodonts were ecological engineers, shaping landscapes, influencing predator populations, and demonstrating remarkable adaptability in a world recovering from mass extinction. Dicynodonts varied widely in size, ranging from small, pig-sized species to massive, nearly 3-meter-long behemoths. Their skulls were specialized for herbivory, featuring a beak-like structure for cropping plants and tusks used for digging, defense, or social display. The jaws were reinforced with powerful muscles, allowing them to grind fibrous plant material with efficiency. Imagine a Permian floodplain at sunrise. A herd of Dicynodonts moves slowly across the landscape, tusks scraping roots and beaks cropping ferns and low conifers, shaping the vegetation as they feed. Every step contributes to the recycling of nutrients, altering soil structure and promoting plant diversity. The body of Dicynodonts was stout and robust, with short, strong limbs adapted for both locomotion and support of heavy weight. Their barrel-shaped torso housed a large digestive system necessary for processing fibrous plant matter. Unlike earlier, more generalized herbivores, Dicynodonts were highly efficient, able to extract maximum nutrients from tough, fibrous plants, allowing them to survive in habitats where other herbivores struggled. Their anatomy illustrates an evolutionary focus on endurance and resilience, essential qualities in the post-extinction landscapes of the late Permian and early Triassic. Dicynodonts inhabited diverse ecosystems, including floodplains, river valleys, and semi-arid scrublands. Seasonal variations in rainfall and vegetation meant that survival depended on adaptability. Herd behavior was likely common, providing protection against predators such as Gorgonopsids and early Archosaurian carnivores. Picture a herd of medium-sized Dicynodonts moving cautiously through low conifers and cycads, juveniles staying close to adults for safety. The landscape is shaped by their feeding, burrowing, and movement, highlighting the role of herbivores as active agents in ecosystem engineering long before the rise of dinosaurs. Behaviorally, Dicynodonts exhibited social and defensive strategies that enhanced survival. Herding provided protection, while tusks and beak structures could be used in displays of dominance, competition for mates, or deterring predators. Fossil evidence suggests that some species may have dug burrows, offering shelter for both adults and juveniles. This combination of physical adaptation and social behavior ensured that Dicynodonts thrived even in environments where food was scarce or predators were abundant. Their strategies reflect a sophisticated balance between feeding efficiency, social interaction, and survival in a challenging world. Predation influenced Dicynodont evolution, driving the development of defensive adaptations. Large size, tusks, and stout bodies made them formidable against smaller predators, while herd dynamics provided collective protection. Fossil evidence shows healed injuries consistent with predator attacks, suggesting repeated interactions with Gorgonopsids, Thrinaxodon, and Postosuchus. By surviving predation, Dicynodonts maintained stable populations, influencing plant communities and predator-prey dynamics in turn. Their success demonstrates the intricate interdependence of species in pre-dinosaur ecosystems, where both predators and prey evolved in response to one another. Ecologically, Dicynodonts were keystone herbivores. Their feeding patterns controlled the growth of ferns, cycads, and other plants, creating open areas that benefited smaller herbivores and encouraged ecological diversity. Their burrowing and movement aerated soil, altered microhabitats, and facilitated water infiltration. By structuring plant communities and indirectly affecting other species, Dicynodonts were more than passive consumers. They were architects of their environment, shaping the evolutionary pressures experienced by predators and competitors alike. Picture a day in the life of Dicynodonts. Morning mist clings to low vegetation as a herd emerges from shelter. Juveniles follow adults closely, learning where to find food and avoid predators. Tusks scrape roots, beaks crop ferns, and bodies trudge through soft soil, leaving trails and depressions. Predators watch from a distance, calculating opportunities, but the herd remains vigilant, communicating through movement, posture, or vocalizations. By afternoon, the herd has altered the landscape, creating grazing paths and nutrient-rich soil patches. Every action reinforces the role of Dicynodonts as both survivors and ecosystem engineers. From an evolutionary perspective, Dicynodonts illustrate the power of adaptation, resilience, and ecological influence. Their specialized feeding structures, robust bodies, social behavior, and environmental engineering allowed them to thrive across millions of years and continents. By shaping plant communities, influencing predator behavior, and maintaining ecosystem stability, Dicynodonts played a central role in pre-dinosaur life. Their legacy reminds us that herbivores were not merely passive participants in the evolutionary drama, they were active, powerful agents shaping the very world in which they lived. As the sun sets over a Triassic floodplain, a herd of Dicynodonts rests near a river, tusks still visible in fading light, beaks occasionally moving as individuals feed on low vegetation. Juveniles huddle close to adults, predators lurk in distant shadows, and the landscape is subtly transformed by the day's activity. Dicynodonts exemplify resilience, power, and environmental mastery, demonstrating that even in the absence of dinosaurs, herbivores could dominate, survive, and shape ecosystems. Their story highlights the complexity, ingenuity, and adaptive creativity of pre-dinosaur life on Earth. Scutosaurus, armored giant. While many pre-dinosaur herbivores relied on agility, tusks, or social strategies to survive. Scutosaurus stood as a testament to brute strength and formidable defenses. Living in the late Permian period, roughly 254 to 252 million years ago, Scutosaurus was a massive, heavily armoured synapsid capable of deterring the largest predators of its time. Its name, meaning shield lizard, reflects its most notable adaptation: a body covered in bony osteoderms, forming a protective shield against Gorgonopsids and other apex predators. Scutosaurus exemplifies the combination of size, armour, and resilience that allowed some species to dominate terrestrial landscapes long before dinosaurs emerged. Scutosaurus measured up to 3 meters in length, with a wide, barrel-shaped body supported by short, robust limbs. Its skull was flattened and broad, featuring tusks and beak-like structures for cropping vegetation, while the jaw muscles allowed efficient processing of fibrous plant material. The most distinctive feature, however, was its dermal armour, rows of bony plates embedded in the skin along its back and sides. These osteoderms were not only protective, but may have played roles in thermoregulation, intraspecific display, and predator deterrence. Imagine a Permian floodplain at midday. The sun glints off Scutosaurus's armour as a herd grazes cautiously, tusks scraping low conifers and ferns, every movement demonstrating both strength and survival adaptation. The body of Scutosaurus was built for endurance rather than speed. Its short, muscular limbs provided stability and support for its massive frame, while a heavy tail acted as a counterbalance and potential defensive tool. Unlike agile herbivores, Scutosaurus relied on its bulk, armoured plating, and tusks to survive encounters with predators. Its anatomical adaptations reflect an evolutionary strategy emphasizing defense and resource acquisition in a dangerous world, illustrating the diverse survival strategies employed by pre-dinosaur herbivores. Scutosaurus inhabited floodplains, river valleys, and open landscapes where vegetation was abundant, yet predators were ever present. Seasonal flooding and dry periods created dynamic conditions, favoring herbivores capable of enduring environmental extremes. Herd behavior likely enhanced survival, providing both protection and social interaction. Imagine a herd of Scutosaurus moving slowly across a riverbank, juveniles staying near adults, predators lurking in the distance. Their presence altered the vegetation structure, trampling smaller plants and creating open grazing paths for themselves and other species, demonstrating how herbivores could shape ecosystems long before dinosaurs. Behaviorally, Scutosaurus exhibited both defensive and social strategies. Its armour protected it from most attacks, but tusks and size were also used for intraspecific competition, mate selection, or dominance displays. Herds may have coordinated movements to protect juveniles and ensure access to food and water. Fossil evidence of healed injuries suggests that Scutosaurus survived repeated encounters with predators, highlighting the effectiveness of its defensive adaptations. The combination of physical protection and social behaviour ensured that these armoured giants thrived in a perilous environment. Predation influenced the evolution of Scutosaurus, driving the development of extensive dermal armour, tusks, and social defence mechanisms. Apex predators like Gorgonopsids often attacked the most vulnerable, but Scutosaurus's armour and size reduced the likelihood of successful predation. Juveniles likely relied on adult protection and burrowing behaviour in combination with herd vigilance. Fossilised bite marks and healed wounds indicate that these armoured giants were rarely easy targets, and survival favoured individuals that combined defensive anatomy with cautious behaviour. Ecologically, Scutosaurus was a keystone herbivore. Its feeding patterns controlled the growth of cycads, ferns, and low conifers, shaping plant communities and creating space for other herbivores. The armored giants' movement altered soil structure, facilitating nutrient cycling and influencing water retention across floodplains. By maintaining stable populations, Scutosaurus indirectly affected predator distribution and behavior, highlighting the interconnectedness of pre-dinosaur ecosystems. Its presence demonstrates that herbivores were active, transformative agents in their environments, not passive participants in the evolutionary drama. Picture a day in the life of Scutosaurus. Dawn breaks over a floodplain dotted with low ferns and conifers. A herd of armored giants moves slowly, tusks scraping roots and beaks cropping leaves. Juveniles remain close to adults, observing social cues and learning foraging strategies. Predators lurk in the shadows, but the herd's bulk, armor, and vigilance deter attacks. By midday, the landscape bears the marks of the herd's passage. Trampled plants, grazed vegetation, and enriched soil. Each action reinforces the ecological impact of Scutosaurus and underscores its role as a dominant herbivore. From an evolutionary perspective, Scutosaurus exemplifies the success of defensive adaptations and the influence of herbivores on ecosystem structure. Its combination of armor, tusks, and social behavior allowed it to survive in an environment dominated by formidable predators and fluctuating resources. By shaping vegetation, influencing predator strategies, and maintaining herd cohesion, Scutosaurus played a pivotal role in pre-dinosaur ecosystems. Its story highlights the diversity, ingenuity, and resilience of life long before the rise of dinosaurs. As twilight descends over a Permian floodplain, a herd of Scutosaurus rests near a river, their armor catching the last rays of sunlight. Juveniles huddle near adults, predators remain at a cautious distance, and the landscape reflects the lasting impact of their presence. Scutosaurus embodies strength, protection, and ecological mastery, illustrating how pre-dinosaur herbivores not only survived but shaped the world around them. Their story is a testament to the complexity, adaptability, and evolutionary creativity of life before the age of dinosaurs. Anteosaurus, giant predatory synapsid. In the late Permian, before dinosaurs ever walked the earth, the terrestrial landscape was dominated by a series of formidable predators. Among the most fearsome was Anteosaurus, a massive carnivorous synapsid that patrolled the floodplains and woodlands roughly 260 million years ago. Measuring up to 6 meters in length, Anteosaurus was a giant among early predators, capable of overpowering almost any prey it encountered. Its size, strength, and predatory strategies positioned it at the top of the food chain, illustrating the intensity of predation pressures in pre-dinosaur ecosystems and the remarkable evolutionary innovations of synapsid hunters. Anteosaurus possessed a large, heavily built skull with enormous jaw muscles and saber-like canine teeth capable of piercing flesh and bone. Unlike smaller predators that relied on speed or stealth, Anteosaurus combined raw power with strategic intelligence to subdue its prey. Fossil evidence suggests its bite could crush vertebrae and tear through thick muscle tissue, allowing it to hunt both medium-sized herbivores and smaller predators. Imagine a Permian floodplain at dawn. The massive predator moves silently through dense ferns, nostrils flaring, eyes fixed on a herd of Dicynodonts grazing nearby, every step calculated and deliberate, a living embodiment of predatory dominance. The body of Anteosaurus was muscular and elongated, with strong limbs positioned for stability and sudden bursts of movement. Its tail provided balance during rapid lunges, while its powerful forelimbs could grasp or knock down struggling prey. Unlike agile synapsids such as Thrinaxodon, Anteosaurus relied on sheer size, strength, and ambush tactics rather than speed alone. These anatomical features allowed it to dominate its environment, demonstrating that in pre-dinosaur ecosystems, size and force were as crucial as intelligence and strategy for apex predators. Anteosaurus inhabited floodplains, river valleys, and open woodlands, thriving in ecosystems recovering from environmental stress and mass extinctions. Seasonal variations in vegetation and water availability created a dynamic hunting environment, favoring predators capable of exploiting multiple prey types. Picture a hot Permian afternoon. Small herbivores huddle near water sources, insects scatter among low ferns, and Anteosaurus waits patiently in the shadows. Its presence influenced the behavior, movement, and survival strategies of countless species, illustrating the central role apex predators played in shaping ecosystems long before dinosaurs appeared. Behaviorally, Anteosaurus was likely a solitary hunter, relying on stealth, patience, and explosive power to capture prey. Fossilized bite marks and healed injuries on prey suggest that it attacks selectively, targeting vulnerable individuals while avoiding unnecessary risk. Juveniles probably grew under the protection of adults or in secluded areas, learning hunting techniques and survival strategies. The combination of size, anatomical specialization, and behavioral intelligence allowed Anteosaurus to occupy a niche with little competition, asserting dominance over both prey and smaller predators alike. Predation by Anteosaurus was methodical and devastating. Using its massive jaws and sharp teeth, it could immobilize prey with a single strike, then finish the hunt with precision. Evidence of healed wounds in coexisting herbivores indicates repeated encounters and an ongoing evolutionary arms race. Predators like Anteosaurus shaped the evolution of herbivores such as Dicynodonts and Scutosaurus, driving the development of armor, tusks, herd behavior, and burrowing strategies. In this way, the presence of a giant predator influenced not just individual survival, but the broader trajectory of pre-dinosaur ecosystems. Ecologically, Anteosaurus served as a keystone predator, regulating populations of herbivores and mid-sized predators alike. By limiting overpopulation of certain species, it maintained ecological balance and allowed diverse plant communities to flourish. Its predatory pressure encouraged vigilance, migration, and adaptive behaviors in prey, creating dynamic interactions that shaped entire ecosystems. Anteosaurus demonstrates that apex predators were not mere consumers, they were architects of ecological structure, driving evolution and maintaining stability across trophic levels long before the rise of dinosaurs. Picture a day in the life of Anteosaurus. The sun climbs above a Permian floodplain, casting long shadows across cycads and low ferns. A herd of Dicynodonts grazes in relative safety, unaware of the predator waiting among the vegetation. Anteosaurus tenses, tail balancing, muscles coiled, and with a sudden, explosive burst, lunges toward its target. A juvenile Dicynodont flees, adults swing tusks defensively, but the predator seizes its prey with lethal efficiency. Later, it rests in the shade of a fallen tree, surveying its territory, alert to other potential threats or opportunities. Every movement reflects the balance between energy conservation, predation efficiency, and environmental mastery. From an evolutionary standpoint, Anteosaurus exemplifies the apex predator archetype in pre-dinosaur ecosystems. Its combination of size, strength, specialized anatomy, and behavioral intelligence allowed it to dominate terrestrial habitats for millions of years. By influencing prey evolution, ecosystem structure, and competition among other predators, Anteosaurus played a critical role in shaping the evolutionary landscape that would eventually pave the way for the rise of dinosaurs. Its story is a vivid reminder that life before dinosaurs was complex, dynamic, and full of remarkable evolutionary experiments. As twilight descends over a Permian floodplain, Anteosaurus rests near a riverbank, nostrils flaring as it surveys its domain. Shadows lengthen, prey animals retreat, and the ecosystem settles into relative calm. Yet the presence of this giant predator lingers, a testament to the power, ingenuity, and dominance of pre-dinosaur life. Anteosaurus embodies the strength, strategy, and ecological influence of apex predators, demonstrating that even millions of years before dinosaurs, life had already perfected the art of survival, adaptation, and dominance in terrestrial ecosystems.